Good morning, algebra students. This is Wednesday, January 5th, and today we're going to be learning about systems of equations. Before I get started, I want to make sure you have the right notes out. So you should have printed these at home, and it says solving systems of equations by graphing. Those are the key words. Make sure you have the day that says solving systems of equations by graphing. All right, now that we're all on the same page, let's get started. Before I talk about what a system of equations is, I need to go over something with you that's going to look a little silly. But I need to show you what happens when two lines cross each other on a coordinate grid. Before Christmas, we were graphing lines all over the place. But each line had its own little coordinate grid. Every line was a separate problem. You can graph lines on the same coordinate grid though, and that's what is going to happen today. So we need to explore what happens when two lines cross each other. One thing that can happen if you're drawing lines on the same coordinate grid is that those two lines might cross each other on the grid. For example, you might have this line and this line right here. These two lines are on the same coordinate grid and they cross each other. Most lines that cross each other only cross each other in one point. Do you all see that? This point right here is the only point where these two lines cross. This line is going to keep going in that direction. That one will keep going in that direction. They're not going to circle back and cross each other again. So usually when you have two lines, they cross each other in one point, at one spot. For these two lines, it's that spot right there. Now, you can also have two lines that are on the same coordinate grid that look like they don't cross each other, but they actually do. Let me show you what that looks like. By the way, you don't have to write any of this down, just watch. Let's say you have this line and you have this line. These two lines are on the same grid and they don't cross each other from what I can see. But do they actually cross each other? I think yes, because remember that lines don't stop there. They have arrows at the end, which means they're going to continue on forever, and they're going to cross each other right about here, right about where I have the letter C, is where those two lines are eventually going to cross each other. So sometimes when you graph two lines on the same grid, they look like they don't cross, but they really do. If you extend the lines, they'll cross off of the grid. Another thing that can happen when you have two lines on the same coordinate grid is that they might never ever cross each other. For example, if you had two parallel lines. There's one line, and I'm sorry it's a little crooked. And there's another line. Now let's imagine that I drew these perfectly straight and that these were two parallel lines. These lines will never, ever cross each other. There is no point where the two lines cross each other. They're parallel and they will stay parallel forever. So this is something else that can happen when you draw two lines on the same grid. It's possible that they never, ever cross each other. The last thing that can happen when you draw two lines on the same coordinate grid is they might cross each other in infinitely many points. They might cross each other everywhere. Let me show you what that looks like. See these two lines right here? Let me put the arrows at the end of them. These look like two different lines on the same coordinate grid. But does everybody see that those two lines are secretly the same line. If you were to extend each line, make each line longer, because this line keeps going in that direction and this line keeps going in that direction, they're really secretly, sneakily the same line. Isn't that crazy? So sometimes you can have what look like two different lines, but they're really the same line. They're just in disguise. So we would say that these two lines cross each other everywhere because they share every single point that's on that line. They share it. They share it in common because they're the same line. Now that we know how lines can cross each other, we can actually dive into today's lesson. Today's lesson is on systems of equations. So before Christmas, we learned what an equation is. This right here is an equation. And this right here is also an equation. When you put those two equations together in the same problem, we call them a system of equations. So a system of equations is simply two or more equations in the same problem. And they also share the same variables. If the variables in this one are x and y, then the variables in this one need to be x and y. So a system of equations is simply two or more equations put together in the same problem. When your textbook asks you to solve a system of equations, that's a weird thing to ask. How do you solve a system of equations? That's strange. I'm going to think about that for a second. I know how to solve an equation with one variable. You solve it like you do the opposite to both sides. But when an equation has two variables, it has infinitely many solutions because it's a line. So how do you solve two equations that have infinitely many solutions? The answer is you find where these two lines cross each other. And this is all written in your notes. Right here. It says to solve a system of equations, you find the point where these two lines cross each other. That is the answer to the system of equations. And that's a weird thing. That's something that's hard to get used to. We're used to solving a problem and having the answer be 8, or the answer is -2. Today, our answer is not going to look like that. Our answer is going to be a point. It's going to be a set of coordinates, x, y. Our answers are going to be the point where these two lines cross each other. So, let's start solving this. In your notes, there's a place for you to solve this system of equations, so let's do it. Let me erase the board. Get ready to do a fresh problem. All right, we are going to solve this system of equations by graphing these lines. We're going to graph this line, then we're going to graph this line, and we're going to see where the lines cross each other. And that is our answer. So, let's get to it. How do we graph lines? Whew, it's been a long time since before Christmas break, hasn't it? And by the way, Evan Dietrich, put your calculator away. You're not using that to graph lines. We are going to graph these lines using what we know already. Now, were different methods that we learned for graphing lines. Since these are written in slope-intercept form, remember y equals mx plus b? I can use that to graph these lines. I can find b, which is the y-intercept. Then I can use the slope to count. Let's use that method for this problem. And if you don't like that method, we'll use a different one for the next problem so that we have a couple different strategies we can use today. Let's start with this line right here. I'm going to label it line number 1. Y equals 3x plus 2. The y-intercept, the thing being added, is 2. That means the line crosses the y-axis at 2. Is that all looking familiar to you? It should be coming back to you now. Now, we use the slope to count and find another point on the line. The slope in this equation is 3. That's the fraction 3 over 1. That means the top number means up and down. The bottom number means left and right. That means I'm going to go 3 up and 1 to the right. So starting here at this point, count up 3 and 1 to the right. That is another point on the line. Now that I have 2 points, I can draw my line. There it is. That is line number 1. I'm going to label it with a little number 1 so I know which line is which. Now I'm going to do line number 2. Y equals 2x. This is line number 2. Let's find the y-intercept. The thing being added is the y-intercept. But there's nothing being added. What does that mean the y-intercept is? There's plus 0 right there. There's an invisible plus 0. So the y-intercept is 0. So on the y-axis, find 0. Now use slope to count to find the next point. The slope is 2. That's the fraction 2 over 1. Slope is rise over run. The top tells you how far to go up or down, how far to rise. The bottom number tells you how far to run, how far to go left or right. So a positive 2 means you're going to go up 2, and the positive 1 means you're going to go to the right 1. So go up 2 and to the right 1. And that should be my line. Plus 2x. Did I solve that correctly? Let me just take a second and see if I did this right. -4. Okay, I did do this right. I just drew it a little sloppily. I drew my blue line a little bit crooked. That's a little better. I apologize, everybody. My first line was a little bit crooked. Okay, that's a little better. If I had drawn these lines really, really well, which I didn't, and I'm sorry, you would find that these 2 lines cross each other right there at that point. So I apologize, my little ruler must have slipped. But these 2 lines cross each other at this point right here. So what is the answer to this problem? This is my system of equations. I graphed the 2 lines. I found the point where they cross. How do I write my answer? Your answer for systems of equations is a point, x, comma, y, where the 2 lines cross each other. So this point right here is your answer. You have to figure out the coordinates of that point. That point right there is to the left 2 and down 4. That is the point -2, -4. That is the answer to this problem. So that is kind of strange. We're used to the answer being 6. Today the answer is not just a single number. Our answer is going to be 2 numbers. The x coordinate and the y coordinate of the point where the 2 lines cross. Let's do another example together. Let's see the next example I have on here. And I will try to draw my lines straight this time. Let's see. This says, solve this system of equations by graphing. Y equals -2x plus 8. and 3x minus y equals 7. All right, let's solve this system of equations by graphing. I've got to graph this line right here. I can do this one the same way I graphed the lines in the last problem, because this says y equals. So remember, y equals mx plus b. In this problem, b is 8. So the line crosses the y-axis at 8. The slope is -2. Make that a fraction, -2 over 1. That means I'm going to go down 2 and to the right 1. So from this point, go down 2 and to the right 1. Now, let me connect those and we'll try to do it nice and neatly. Okay, hopefully that's neat enough. Now, I have to graph the other equation. Does anybody see a problem with graphing this equation? I think the problem for this one is it's not in the form y equals mx plus b. So, I can't just look at the y-intercept because I don't know what the y-intercept is. It's not in the y equals form. Now, lucky for me, there is a really easy way to graph lines. And this method works for every line. It works for lines in standard form. It works for lines in slope-intercept form. It works for lines in point-slope form. It's really, really easy. It was the very first way we ever learned how to graph a line, by making an XY chart. So for this equation, I'm going to make an XY chart. I pick whatever number I want to be X, and that lets me figure out what Y is. And then that is a point on my line. So pick any number you want to be X. You know I like to pick X equals 0. If X equals 0, let's figure out what Y is. Put a 0 right here. 3 times 0 minus y equals 7. 3 times 0 is just 0, so we have -y equals 7. And you can pick this negative sign up and throw it over there. This would be y equals -7. So if x is 0, y is -7. Let's pick another number to be x. I'm going to make x get bigger so that I won't have to mess with negative numbers. So I'm going to say, how about if x is 3? If x is 3, I will put a 3 right there. This would be 3 times 3 minus y equals 7. 3 times 3 is 9, so 9 minus y equals 7. 9 minus what number makes 7? What is that missing number? 2. 9 minus 2 makes 7. So 2 is the missing number. So if y is 3, or I'm sorry, if x is 3, y is 2. There, right there in that XY chart are 2 points on the line. 0, -7, and 3, 2. So graph those 2 points. 0, -7 is here. 3, 2 means go over 3 and up 2. It's right there. And draw your line. There we go. I just graphed these 2 equations. This one I graphed by using y equals mx plus b. This equation I graphed by making an XY chart. I have my 2 graphs, my 2 lines up there, and where do they cross each other? Remember, the answer is always a point where the two lines cross each other. Where do they cross? They cross right there. That looks like it's the point 3, 2. 3, 2. So the answer is the point 3, 2. That's the answer, where the two lines cross each other. Let's do another example. Okay, let's see. Our next example is x plus 2y equals 1 and x plus y equals 4. All right, we have to graph these lines. Neither one of these is in the y equals format. So for these two lines, I think the easiest way for me to graph these would be to make an XY chart. So for this equation, I'm going to draw an XY chart. I pick anything I want to be X, anything at all, and figure out what Y is. I'm going to say X equals 1. If X equals 1, then what is Y? Take 1 and put it right here in the equation where X is. 1 plus 2y equals 1. Now solve for y. Y is being multiplied by 2 and they're adding 1. You can subtract 1 from both sides. You get 2y equals 0. And what number times 2 gives you 0? 0. So if x is 1, y is 0. Let's do another point on this line. And I'm sorry I have to erase, but I don't have a lot of whiteboard room here at home. So let's say x is 3. I'm going to make x equal to 3. I pick any number I want, and I want x to be equal to 3. So take 3 and put it where x is. This would be 3 plus 2y equals 1. Solve for y. Y is being multiplied by 2 and they're adding 3. Subtract 3 from both sides. You get 2y equals negative 2. Y is being multiplied by 2, so you have to divide by 2. And you get y equals negative 1. So if x is 3, y is negative 1. Those are 2 points on my line. Let me graph them. The point 1, 0 and the point 3, negative 1. 1, 0 is here. 3, negative 1 is there. And connect the dots. Try to connect them as neatly as possible. Okay, next, I'm going to make an XY chart for this equation. Make another XY chart for the second equation. X plus y equals 4. Let's say x is 0. If x is 0, put a 0 right there. 0 plus y equals 4. That is just y equals 4. So if x is 0, y is 4. What about if x is 1? If x is 1, then this would be 1 plus y equals 4. 1 plus what makes 4? It's 3, right? So if x is 1, y is 3. These are 2 points on this line. So graph them. 0, 4 means don't go left or right, go up 4. 1, 3 means go over 1 and up 3. That is my line. connect the dots as neatly as you can. And find the point where the two lines intersect. It looks like they cross each other here. Yep, that looks like the point 7, -3. You go over 7 and down 3. So the point where those two lines cross each other, the solution to this system of equations is the point 7, -3. Now, we're running low on time, so I just want to quickly point out what will happen in the last two examples in your notes. For this example right here, if you graph these two lines, what you're going to find is that they are really the same line. You're going to find out that the top line and the bottom line completely overlap. They make one big long line. So the answer for that system of equations is infinitely many solutions. If you graph two lines and they end up being the same line, the answer is, where do they cross? They cross everywhere. So you write infinitely many solutions. For the last example, this one right here, you're going to find, if you graph those two lines, you're going to find that they are parallel to each other. Because look at them, look at very closely. They have the same slope. The slope for both of those lines is 4. We learned yesterday that when lines have the same slope, they are parallel to each other. So these lines don't cross each other. There is no point where they cross each other. So the answer for this last one is no solution, because the lines never cross. All right, I'm sorry we ran out of time for those last two problems, but you can do them at home on your own time. Won't that be fun? I know you can't wait to do them. So the next thing you guys are going to do is you're going to do some problems in your workbook. And let me find what page we're on. We are now in chapter 6. So in your workbooks on page 171. Page 171 in our workbooks, you are going to do, let's just do numbers 1 through 6. No. 1 through 5. Numbers 1 through 5. You will need some graph paper, so I'm going to have to remember to tell our substitute or Mrs. Harris where the graph paper is so that you guys have something to graph on. But I'll take care of that. I'll make sure that we have that before you learn this lesson. So graph the systems of equations on a coordinate grid. See where they cross each other. Make sure you use a ruler so that your lines are nice and straight so that you can see what the point is where they cross. When you're ready to check answers, the answer key is not on the white shelf. Because we're in a new chapter, you guys are going to have to find the new answer key. It is going to be over on one of the bookshelves by the window near the function machine. There's a stack of teacher materials, and there's an answer key book that says chapter 6. So somebody's going to have to find that and look up the answers, and then you guys can help each other. If somebody missed number 4, somebody can offer to come to the board and show the class how to solve number 4. Okay? So take a little time, work on these workbook problems, check your answers, and then help each other figure out what you all did wrong on the problems. If you can do this lesson without getting into trouble, then there's no homework tonight. So hopefully that will happen. And I will see you in tomorrow's video. Goodbye, everybody.